Okay, hey guys. Today I'm going to explain about trigonometry and the four quadrants and trigonometric graphs. So, first things first, I think you're all pretty familiar that trigs are ratios. So sine, cos, and tan, all these things are basically ratios of sides of a triangle. Let's say this is my theta. Sine would be so, opposite over hypotenuse. So the opposite of theta is b, and the hypotenuse is c. So sine theta would be b over c, right? So it's pretty straightforward, as you can see, but it gets really complicated and you can do really cool things with this later on. So first things first, every angle in a right angle triangle that isn't the right angle is an acute angle. So this is pretty easy when dealing with sine, cos, tan, but sometimes you can also use these things to find the ratios of things in a triangle with an obtuse angle or a reflex angle. So these might get tricky. You can't just simply find the hypotenuse and this one because it's no longer a right angle triangle. So how do you find the ratio of these things? Well, we'll see. So this is a unit circle. A unit circle is basically four quadrants and it's arranged following the degrees of an angle. So first you always start with 0, then you turn anti-clockwise. So 0 to 90 to 180 to 270 to 360 again, completing the circle. So a unit circle, generally the radius of the circle is 1 unit lah. So this here, this is 1 unit. What you can do with this is that they can give you coordinates of points on the circumference of this circle, and then you can draw a triangle from it. For example, I give you this point. Maybe it's 1, 1. So from this angle here, you can draw an angle from 0 to the line, this angle, right? So then the question might ask you, what's the sine of this angle? How do you do that? Well, remember sine is the opposite over the hypotenuse. So you can actually just find the opposite. What's the opposite? Since this is a graph and this is the 0, this is the coordinates. So this is the x-axis, this is the y-axis. So the height, or the opposite of this theta, is 1. And this is also 1. So how do you find the hypotenuse? Well, you can use Pythagoras theorem to find whatever this is. And sine is so it's opposite over hypotenuse. So you can use that as well. But another cool thing about this unit circle is you can use it to find obtuse and reflex angles. So let's say I have an angle that is more than 90 degrees. I have an angle this much. The cool thing about unit circles is that you can find corresponding angles. So if this is, let's say, is 150, I want to find the sine of 150. Sine 150 is actually the same as sine of this one. So this is 180 minus 150, you get 30. It's sine 30. So what are the rules for this? Well, I'll explain later on. So by now you should know that sine, cos, and tan, they have corresponding angles or equivalents. That means that sine of one number, 1 degree, might be equal to another sine. So for example, sine 150, as you saw before, is the same as sine 30. So you can actually test this out by getting a calculator and just typing in sine 150. And you can see you get 0.5, and sine 30 is 0.5 as well. The thing is, obviously you can't memorize all of these equivalent numbers, so how do you know what is the same as an obtuse or reflex angle? So we use the four quadrants. So first things first, you should know what the four quadrants are. They are, as Mr. Das said, it's add sugar to coffee, or all. So all the sine, tan, and cos are all positive. Sine, when only the sine is positive. Tan, only when the tan is positive. And cos, when only the cos is positive. Got it? So here is the butterfly thing. It's basically when you have these four quadrants, where do you measure the angle that is equivalent? It's always the angle nearest to the x-axis. So this is the x-axis. If you draw an angle here, do you measure this one or this one? It's always this one, nearest to the x-axis. If you draw it here, it's here. Draw here, it's here. If you draw an angle here, it's here. It's always measure these ones. Okay, let's test it out. So, I have sine 150. How do I find what sine it's equivalent to? First, draw this angle. Start from 0 and draw 150. 150 is more than 90, less than 180, so let's just say it's here. This is 150. Now, again, let's see which angle I should drop down on. So this is 150. Do I draw it here, here, here? It's this one, because it's near to the x-axis. So if this is 150, what's this one? It's 180 minus 150, so you get 30. So let's say it's sine 30. And again, we checked it out on calculator just now. It checks out. They're both equal 0.5. That's all on rel. So, and remember the quadrants. If all plus, that means whatever you land here, the answer, if it's any of these, you get a plus. For here, okay, here's a sine. I got sine 30, and it's in the sine house. Therefore, it's positive sine 30 or just sine 30. Let's see what happens when you do 10. So, 10, 150. You do the same procedure. You start from here. You draw the angle 150, and you have what's left. So where do you draw it? It's here because of this one, the butterfly. And it's 30. Now, let's say we put this, and we test it out on the calculator. 10, 150 equals to negative 0.57. But 10, 30 equals to 0.57. So they're not the same. So why is that? Because we forgot to add the negative. Here, this angle, this line is inside the sine house, and only the sine can be positive. So the 10 must be negative. So then we put a negative in front. So the answer is 10, 150 equals to negative 10, 30. Got it? In your calculator, always put the negative before the 10, 30. Don't put 10, negative 30. Actually, I'm not sure whether that'll work or not. I'll check later. Anyway, let's try again. So now we have sine 350. Just erase this. Sine 350. So let's draw the angle 350. 350 is almost as much as 360, so it's almost all the way here. Let's draw it here. So this is 350. Again, where do we draw the corresponding angle? It's the one nearest to the x-axis, so it's here. What is this angle? 350. So this whole thing is 360. 360 minus 350 is 10. So this is 10. Sine. Whose house are we in? We are inside cos's house. So sine must be negative. So we put a negative in front, 10 degrees. Therefore, sine 350 equals negative sine 10. We can test it out. Sine 350 is negative 0.17. And negative sine 10 is negative 0.17. So it's the same. And now let's try with cos 400. I need to get a better eraser. This is a sad way of life. Okay, so cos 400. So as you can see, this is more than 360. And in real life, logically, that makes no sense whatsoever lah. But let's just say we are given this. That would be, we go around 360, then we come back again. So 360, come back another 40, which makes 400. So come back another 40 will be here. So now we're back here again. Where do we draw the angle? Closest to the x-axis, it's here. Got it? And this is 40 lah. So cos 400, which house are we in? We're in the all house, so everybody's positive. Therefore, cos 40. And this is positive, so just leave it like that. Get it? Then, now, moving on to the graphs. So, as you all saw just now, sine cos 10 are all ratios between lengths of a triangle. When you have an angle and you put a sine or cos of 10 in front of it, you get a value, and that's the ratio, right? So this is basically a function. So your fx is this one, and your x is this one, the theta, and your fx or the y is the result, the ratio. So you can actually draw a graph out of it. So this is the general. They won't ask much about this outside of paper 1, because they'll basically just ask. They put a point here and ask, what is that? So we can just, as long as you memorize the graph and just generally understand how it works, you can answer it lah. But let's just see the cool theories behind it. First things first, so let's just make a list out of random angles lah. Okay, the ones highlighted are the important ones, like, you know, these ones: 0, 90, 180, 270, 360. So I mark those on the graph, and I mark 0, 1, negative 1. So this is my graph. Let's test it out. So sine 0. So if your angle is 0, your sine would be, well, it would be 0. So let's plot it here lah. Next, let's just try out sine 30. You all saw just now it was 0.5. So if you plot it on the graph, sine 30 would be around here lah, 30 somewhere here, and 0.5 would be in between, so it's here. It's starting to have a shape. So now let's try sine 90. This means that you have an angle of 90 degrees, and you sine it. What's the sine of that 90? Sine 90 is 1. 1 over here. Okay. Now, you can see it's going up, right? And now we can try with sine 100. And you get this number, 0.98, blah, blah, blah. It's nearly 1. It's a bit less than 1. And sine 180. And it goes back to 0. So you can see it goes back down. So if you connect the dots, you'll get a curve like this. And if you keep doing it for all of these angles, like, you can just try it from sine 0, sine 1, sine 2, sine 3, all the way to sine 360. You can plot it on a graph, and it will actually just look like this. It goes through this one, sorry. So the graph actually stops at 360 because there's no such thing as an angle bigger than 360. So you can just stop it here. In science or in music, this is called a sine wave, because the sound wave of a note on a keyboard, it looks like this, and that's really cool. So this is a sine wave on a sine graph. Just remember how it looks like. It's all in your success book. You can just search up how a sine, cos, and tan graph looks like. It's all the same. Just remember what point goes where. For example, they might ask you, they'll give you a point here. They tell you this is the highest point on this one. And they give you maybe they give you the x-axis, 90. So what's the y-axis? Well, it's 1 now. Yeah, that's it. Just memorize this graph. Now, we can try it out with the cos graph. So all 3 graphs actually look different because the way the ratios work are also different. Let's try cos 0. You get 1. Cos 0, get 1. Cos 30. You get this big number, 0.86. 0.86. Nearly 1, so it's here. Cos 90. It's 0 again. Cos 100. You get negative something, so negative 0.1. It goes down below the graph. Negative 0.1. It's here, I guess. Cos 180. Negative 1. Get it down here. Cos 270. You get 0 again, so then it goes back up. And then if you keep plotting it, in the end, the graph will look like this. Like a little U-shaped bowl like that. So the graph looks like this. So this is a cos graph. And again, it stops here because there's no angle bigger than 360. So remember, sine graph like this, like a little wavy, and a cos graph is at the bowl, or underwear for some people. Next, tan. So tan graphs are a little special. So for sine graph and cos graph, we can actually make sound waves out of it in real life. That's cool. But tan graphs we can't because of this thing. So let's try it out. Tan 0 is 0. So get back there. Now tan 30, it's 0.5. Doesn't seem much of a change. So sine 30 is here, 0.5. Just a small thing here. But then let's skip up to tan 80. It's 5.67, and it's like already here lah. This is 80, it's not even touching 90 yet. And then let's try 89. Tan 89. You get 57. It's increased from 0 to 0.5 to 5 to 57. Let's just say it's up here. It's actually a lot further. And now let's try 1089.9. It's 572, which would be even higher. And if you can just keep going, 1089.99999 is this number that's so big. And at the end, if you have 1090, you get a math error. So the calculator cannot calculate that because it's actually infinite. So the line actually from here connects and then it goes straight up before as it touches 90. So this is a straight up forever. So but then let's do 1091. You get negative 57.2. Negative all the way down here. And I think you all see the pattern already. Let's keep going. 180 is 0. So it goes up, skips over to infinity, comes back down from negative infinity, and goes back up where it touches here, 180 at 0. And then if you keep calculating, you can just keep calculating. It actually goes like this. It goes 10, 270. Yep, math error again, so it goes back up. And it actually just repeats. So this tan graph, if you see a graph that looks like this and it's just like infinite loops of that, it's a tan graph. So I think you all should remember by now. Sine graph is a wibbly wobbly. Cos graph is an underwear. And tan graph is heat rising up from your cup of coffee. Okay? So basically the question will ask lah. They'll give you a point on here. For example, here. Oh, I can't do 10 now. So here. They'll ask, what is the coordinates of this point? They won't give these numbers, and they'll just draw the graph, just blank like this. And they'll give you this. What's this? Well, you should know it's -1. Wait, it's 180, -1. That's the coordinates of it, because it's always like this. No matter what size triangle you have, these are the ratios, they're always the same. You guys okay? Any more questions? I think you just text Kate or something, because I've pretty much covered the trigonometry lah.